بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي صدق الله العظيم. Welcome again students to the subject engineering drawing. Today our topic is dimensioning and this is our week 4th and it's also our 4th lecture of the 4th week. As I have discussed in the previous lectures that this engineering drawing subject is taught in first semester of the first year and it has no prerequisites. I'm your course teacher engineer Kamar Zaman. If you have any query you can access me to my email that is kamar.sewal@sood.edu.pk. I will upload all the helping materials related to the dimensioning to the portal.soot.edu.pk. Coming towards the main topic, that is dimensioning. So we will see the dimensioning today in our lecture. First of all, I want to show you the outlines of the lecture, that what topics are included in our lecture. First of all, we will see here the outlines. So in the outlines, first we cover dimensioning, that what is dimensioning and why it is used in engineering drawing. The second topic of our outline is types of dimensioning. So types of dimensioning are given here. That first one is size or functional dimensions and the second one is location or datum dimensions. So these two types we will see in detail for dimensioning. The third topic of our outline is placing of dimensions. So it shows that how we can place the dimensions. So for this purpose there are also two systems. The first one is known as aligned system and the second one is known as unidirectional system. So in the first one we will see the aligned system, that how dimensions can be kept. For example, I have written here 3 centimeter, while in the unidirectional we will see that the dimension should be kept in same or in unidirectional dimension. The fourth topic of our lecture will be general rules for dimensioning, and the last one, that is fifth one, the practical hands-on dimensioning. So we will also see the practical hands for giving dimensions to the object in engineering drawing. Coming towards the topics one by one. So first of all we will here see the dimensioning and its explanation. So in the dimensioning, every drawing, whether a scale drawing or a freehand drawing, besides showing the true shape of an object, must apply its exact length, the second one breadth, the third one height, fourth one sizes and position of the holes, grooves, etc., and such other details relating to the manufacture of the object. So what dimensioning says? It says that whether it is a scale or freehand drawing, it's necessary that we must apply the dimensioning to that object. Like for example, if we have any object that is here, I will show you only a simple square. So for the square we will provide here its original length or width. So providing length or width or any relevant detail of that object is known as dimensioning. So dimensioning is much more necessary in engineering drawing. Supplying this information on a drawing sheet is called dimensioning. So these information like length, breadth, height, sizes, and position of holes, grooves, etc. on drawing sheet is known as dimensioning. For example, if we have this drawing sheet and there is, for example, something like hole, or there is something like a pulley, like this one is a pulley, and from this pulley here is a rope. So the dimension shows its length, its width, its height, its diameter, or grooves diameter. So dimensioning used for that purpose. Like here is a hole. So in the hole we can draw a leader line and we can attach a note here. For example, this hole has a diameter of 3 centimeter. So this is known as a dimensioning. So the exact length, breadth, height, size, and position of holes, grooves, etc. that can be drawn on the drawing sheet is known as a dimensioning. Lines, figures, numerals, symbols, notes, etc. are used for this purpose. Here you can see that we have used a line, that is dimension lines. Figures, numbers, symbols, notes, etc. can also be utilized for dimensioning purpose. Now coming towards the types of dimensions. There are two main types of dimension. The first one is size or functional dimension. The second one is location or datum dimensions. We will see each one by one, that what does a size or functional dimension mean, and the second one, that is location or datum dimensions. In the size or functional dimensions directly affect the function or working of a product and may be of the size or location of a location types. In the functional dimensions, it shows the function of any object. For example, if we have a pulley or if we have a screw, so this screw has a part like this one. So this part is utilized for screwing purpose, to be tight in any object. Like a screw can be tied in a table. So this part is a functional dimension. The dimension used for this purpose is known as a functional dimension or size dimension. Functional dimensions should be based on the function of the component, and they can also show the method of locating the component and its appropriate assembly, thus ensuring its correct working within the whole product. As I have told here, that the screw can be used for tightening any two objects, any two parts. So here this is known as a functional dimensions or size dimensions. On the other hand, you can see here the detail of a function or size dimension. Here you can see that a mechanical part is given to us, and in the mechanical part here you can see it's the first part, that is shaft, the second one is pulley, and the other is body. So it is clear here that there are function and non-functional parts. The first one that here is shown, that this one is non-functional. This part is also non-functional. However, you can see here the pulley, this one is a functional dimension. So it's also here you can see that is a functional dimension. This one is also a functional dimension. This one is also a functional dimension. Those parts which can be utilized for different purposes are known as a dimensional or size function. Here you can see the the groove or a pulley, it's also a functional dimension. Here it's also a functional dimension. Here you can see the part, this one, that is a function dimension. It's also known as a function. However, on the other side you can see here that is the whole overall part that is not used for purpose of utilizing the pulley. This is a non-function or non-function dimension. And now we will see the other part, other type, that is location or datum dimensions. So what is the location or datum dimension mean? It's clear from the term location. So location or datum dimension shows the exact position of various constructional details within the objects. Like here we have an object, for example this one or this one. You can see here that there is a hole, and this hole is shown by any like this. There are two holes, and these two holes are explained here from this dimension line, that is 38. It shows that here the distance between them is 38 units. So it shows the exact location or exact details in the object or in the drawing. So this one is known as a good method. Here you can also see that the same is used. However, this position of taking the dimension is not good, because here, like in this position, the image is very clear, and it can easily be seen that there are two holes and the distance in between them is 38 units. While on the other side, if we rotate the same object and make it a keep it as horizontal like this one, so these two holes may be come here. The first one is here and the other one will be here. Watching these two from side view, the position of the hole will be shown like this. So the distance in between them will be the same, that is for the other one. However, the dimensioning will not be seen clearing, or the position could not be recognizable easily. So this method is preferable instead of this one. Now placing of dimensions, that how we can place the dimensions. So there are two systems of placing dimensions. The first one is aligned system and the other one is known as unidirectional system. The first one is aligned system and the other one is known as a unidirectional system. Here it's clear from the name that is aligned system. So on the other hand, here you can see that the other system is unidirectional system. Coming towards each one by one, aligned system. In the aligned system, the dimensions are placed perpendicular to the dimension line in such a way that it may be read from the bottom edge or the right hand edge of the drawing sheet. This statement says that if we have a sheet like this one, and in this sheet here we have any drawing. For example, I have a car here, and in this car, if I will take its dimension from this position to the end of the car, so and you can see the dimension from this outline to this last one. So for example, it's a 10 feet. For example, we will consider here it's a 10 feet in length. So writing the dimension in such a position, that is 10 feet upper on the dimension line, is known as a aligned system. On the other hand, if we see this part, like this one, that is also its other part. So here we can see that it is a 2 feet, so 2, and I will show you here a feet. So writing in the in the direction of the line, that is the dimension line, it is known as uh, aligned system. The dimension should be placed near the middle and above, but clear of the dimension line. This statement clarifies that if we want to write any dimension for any object, so the dimension should be given at above, like this one, 3 centimeter, and must be in the center, like here that I have written, not like this one. If I write it here or I write here, these two positions are inappropriate for dimensioning system. So this method and the placing system is known as a aligned system. Here are two figures for aligned system. It's a figure C, and in the figure C you can see that the part is shown by 40 units. So the line that you can see here is a dimension line, and the unit is written on above the dimension line. Here you can see that the line is vertical, and with the vertical line the unit is written parallel to the line, dimension line. So in the aligned system, where you want to give any an aligned system, you should keep in mind that the unit you will display should, or the numericals you will display should be parallel to the dimension lines. Here you can see that in the line system I have explained the line that the unit should be on the dimension line and must be in the center. So this one is accurate. On the other hand, if you see the same unit is written in the center, but however it's beneath the line, so this case is improper. Here it's also beneath the lines or on the other side, and here it's also not okay. However, this one is appropriate method for aligned system, so you will prefer this one, for example 40, or this 30, or this 30. However, these three positions are improper and not acceptable in aligned system. The other system that is known as unidirectional system. So in the unidirectional system, all the dimensions are so placed that they can be read from the bottom edge of the drawing sheet. The dimension lines are broken in center for placing dimensions. These two statements says that, for example, if we have a drawing sheet, and the drawing sheet, if we want to give any dimension, so the dimension line must be split in two parts in the center. Like here I have split this line into center, and I will write the unit here in the center. The first statement says that dimension should be given that it can be readable from the bottom edge. So you can see from the bottom edge that it can be easily readable. If I will draw a line here like 30 centimeter, so it can also be seen and readable from the bottom edge. So this is known as a unidirectional system. However, if I will draw a line like this one, that is vertical line, vertical dimension line like this one, I will also give the same unit in this not the unit, the same direction. I will give the same direction, that is like here 30, like here 30 in the same direction. It is in horizontal, I can say here be here is also a horizontal. So there in this case I will also give its a position in a horizontal position. So this is a unidirectional system. If you will draw a line inclined, parallel, horizontal, vertical, however, the dimensioning or the placement of a unit must be of the same direction. For example, here I will also give 50 centimeter, for example. So this is the unidirectional system generally says us. Here you can see the exact picture of unidirectional system. This method is shows that the unit that is given must be in the center and the line would be split apart into two parts. And this method is also okay. However, here this one is not okay because it is in the aligned system, as the in which direction the line goes, the writing or the unit which we display would also be in that dimension line. So this method or procedure is or system is not applicable here because it is a unidirectional system, not a aligned system. Here you can also see that every unit is in the one direction, like 25, 100, 38, 40. These units can also be seen that that is for diameters. Here it's also all the units are in the same direction. Here the angle is also in the same direction, that is horizontal, and it can be seen from the bottom edge. Now let's see the general rules for dimensioning. Dimensioning should be done so completely that further calculation or assumption of any dimension is avoided. This statement says that the dimensioning that we will give to any drawing must be clear, that the other dimensions, calculations or assumption that should be avoided. Every dimension must be given but none should be repeated. Like an object that is for example, again I will consider here a car, and if I will take this car and I want to take a dimension of the car, that is outline from the outlines from the start to the end, and this is a dimension line. For example, this is a 40, not 40, however I will consider here it's a 5 feet car, and again I will take it 5 feet from the above. So taking dimensions 2 times should not be, or 2 or more than 2 should not be used, because as you can see here that I have used 5 feet dimension above and 5 feet below. Both dimensions are repeated, so this method should be, or this repetition must be avoided. Dimension, in the third statement, dimension should be placed such that it can be viewed easily or read easily. Like here I haven't kept the dimension clear, but in the upper case I have kept the dimension a little bit clear. So the dimension should be given clear that it can be easily read. And the fourth rule, mutual cross section of dimension lines and hidden lines or other lines should be avoided. Mutual cross section must be avoided here, like here, for example, for a car uh, or vehicle. For a vehicle, we take a center line. So here you can see that the center line and dimension line is uh, crossing each others. So these crossing must be avoided in providing dimensioning. An outline or center line should never be used as a dimension line. This fifth rule says that the cross section, the center line like this one or outline may not be, should not be used as a dimension line. Like I have a square like this one and I want to use the same square side for a dimension like this position. So this side is 5 feet and taking the same outline as a dimension, so it is not acceptable in engineering drawing. You must take another line or draw another line that is known as a dimension line for dimensioning purpose. Like here I will draw a line and I will write here 5 feet for dimensioning. So you cannot take any outline or center line for a dimensioning purpose. A little bit practical hands that are necessary in dimensioning. Let's see what are the practical hands that we should use and follow. The first one is dimension lines should be drawn at least 8 millimeter away from the outline and from each other's. For example, if we have an object like this one and we want to show the dimension, so for giving dimension we will draw the two lines, dimension line 1 and dimension line 2. So this statement says that dimension line should be drawn at least 8 millimeter away from the outline and away from each others. The distance must be kept here 8 millimeter and here also 8 millimeter apart. So the spacing provided in the dimensioning line must be 8 millimeter, that it can easily be seen and recognizable. The other hand says that smaller dimension should be placed nearer the view and larger dimension further away. Like in this scenario, that the smaller dimensions should be placed nearer the view. Here you can see that this position, it's for example 3 feet. I have written 3 feet and I have drawn a line of dimension above, and for larger dimension I will keep the line 8 millimeter away from the smaller dimension line. So this must be followed for all drawing. For example, if we have a stair like this one and I want to construct a dimension line, so for the first step I will draw a little small dimension line. For the second one, 8 millimeter apart every dimension line. For the third one, and finally for the fourth one. So keep in mind, if you are drawing a dimension line for every part of the drawing, so keeping the shorter or smaller dimension nearer to the view and then the second one, the third one, and in the last keep the largest dimension of the object. The third hint: arrowheads should be ordinary, be drawn within the limits of the dimensioned features, but when the space is limited, then dot may be used. The third hint says that if you want to draw a dimension line, you can use a head. However, if the space is limited, you can also draw a dot like this one. So for dimension purpose, if space is limited and you cannot able and to draw the head or arrowhead, so you may also draw a dot in the place of a arrowhead. Coming towards the fourth hint, practical hint, that is, for dimensions of cylindrical parts should be as far as possible be placed in the views in which they are seen as a rectangle. For example, if we have a cylindrical part, so the dimension should be away or further away from the cylindrical part of the objects. The dimensions indicating a diameter should be placed by the symbol phi. I will explain all these steps or hints in the figure. The third one or the sixth one hint is that the dimension of a cylinder should not be given as a radius. We will use the dimension for any circle or for any cylinder. We will take diameter, not a radius. Letter SQ should be precede the dimension of square cross sections, and the word sphere must be placed before the dimension a spherical part. So let's see all of these hints in the given figure. As we have seen the hints, the hint says that the practical hint for the diameters is that we must write full diameter for any cylinder or any circle. So here you can see that the diameter is given to the circle or any cylinder. So this phi symbol should be used, not a radius may be taken like this one. For example, if we have radius 30, diameter 30, then radius will be 15. However, we are not able to take the radius of the circle or the cylinder. In this case, in B, we can also take diameter from this point to this one and can write here phi 30, or in this case we can write phi 7.5 unit. So this is the method for a circle or spheres or cylinders, not spheres. If we have an object, and in that object that object have a part like a square, so we will write SQ before the unit, so it shows that the object is a square. So SQ 3 centimeter is an example given here. So the SQ 3 centimeter shows that this is a square. If in the drawing, if a sphere is given, so for a sphere we will write sphere and the unit. If it is in a centimeter and millimeters or whatever it is, so we will write sphere first for the spherical object. Hope you got the lecture. Thank you. Assalamu alaikum warahmatullah.